Hey, hello, and welcome to the show. It is me, JP, and we're here for JP's product pick of the week. Thank you very much for stopping by. Thanks for jumping over into our various chats. We've got the YouTube chat over here. If you're on YouTube, hello to Dave Odessa. And this is the place to be if you're somewhere else that doesn't seem to have a chat going on, and that is the live broadcast chat channel within the Adafruit Discord server, which you can get to by heading over to adafruit.it/discord, and you'll have an instant invite. Just say yes a bunch of times, and Discord will bring you to the splendors and wonders of this very channel right here. I want to say hello to Blitz City DIY and Sam J. Ohio and Toddbot. Hello. Thanks for stopping by, everyone. So what's going on here today? I've got a, let me get that out of the way. I've got a new product pick for you. And if you want to go check it out right now, you can head over to that QR code, that URL right there. It's product 6479. Big thanks to Jelly and the rest of the products team, new products team, for stashing a bunch of these before the show and then giving this a super great deep discounted price. There are 100 of them in stock. The price is cut in half, 50%. Go there, check it out, because this show is broadcast from inside the page, so you can continue to watch, and you can, at some point, if you decide, hey, this is it, this is the thing for me, I want this, I want to try this out, hit buy, throw it into your cart. You can get up to 10 of them, no resellers allowed during this discount pricing. Throw them in your cart, get them before they disappear or before the show is over, because we don't do any rain checks or things like that, no coupon codes. It's just priced to sell right now during the show. So go there, check it out. Hello to Thin Man, who has just said hey from windy Colorado. Hold on, everyone's going to be a bumpy ride. All right, good luck to you there with the wind. The next thing I'll do is usually I'll play a new video from Lamore for the product pick of the week, new segment on Ask an Engineer, I should say. However, this one, I think this one had maybe I'll play that in a second. There was a eye on NPI for this one. Should I do that? Let me see if I can find that video. I don't think I set that one up, but I think I grabbed it and that one's trimmed and ready to go. Let me just look right here. Yeah, I've got an eye on NPI video. Okay, so let me throw that onto a new layer for you right here. Just bear with me while I add a media file and check this out right here.
Yes, AMS Osram, like it's a Burge, and AMS used to be Taos, have a new sensor out. I thought it was pretty cool. This is a true color sensor called the TCS. Wait, let me get the exact right number. It's the TCS 3530, but on DigiKey it might be the 3532. And this is you can see the sensor in the middle. It's a fully embedded true color ambient light sensor with flicker detection. And that's what I thought was interesting. It doesn't give you RGB output. It gives you XYZ output, and it can do flicker detection up to 7 kilohertz. So this would be, yes, AMS Osram, like it's a Burge, and AMS used to be Taos, have a new sensor out. I thought it was pretty cool. This is a true color sensor called the TCS. Wait, let me get the exact right number.
Well, oops, that went all weird. That's okay. So that was a color sensor that Lamore was looking at. It's actually a slightly different one that she ended up going with for this breakout. So let me show it right here. That right there, that's the product pick of the week this week. It is the TCS 3430, which is a tri-stimulus color sensor for ambient light and color. This is in a STEMMA QT form factor, easy to plug and play because it's I2C. You don't even need to solder any pins to it or put it down on a board. You can just plug in some of our little STEMMA QT/quick connectors there into your microcontroller. And let me give you some interesting facts about this one. So this is pretty specifically a CIE 1931 tri-stimulus color sensor. So this fits the, I'll show you a real demo with this in a second, but it fits this chromaticity chart, which is the French CIE, which is an international color scientific foundation, something like that in French. And it is a color chart that maps to human vision pretty well. So this is used for things like white balance on cameras, white point adjustment on displays, color sensing, ambient light sensing, optical identification, and color matching. But specifically, you will find this type of sensor really useful when you want to match a display to an ambient light condition. So a phone that you want to be able to change as your lighting conditions are adjusted through the day, or if you have a device that's going indoors and outdoors, to be able to try to adjust automatically white balance is a really useful sensor. It's also used for things like signage. So when you have digital signage that you want to blend in with set pieces and props. Think of things like amusement parks, where you might have elements that are physical objects and some elements that are displays, and you kind of want to blend that to hide that illusion. This is the type of sensor that you can use so that if there's a change in lighting, if cloud goes by, if sun comes out, you can make adjustments so your displays look a little nicer. So this is available for, we have a library for Arduino and for CircuitPython and Python if you're using something like a single board computer using Blinka. And I'm going to show, let me show you the front and back of it there, so you can see this has a single I2C address, so you need to use multiple I2C lines or a multiplexer if you wanted to be able to use multiple of them, but it comes on with address 39. And you can see the sensor is right there in the middle. It's that little package there. And this is interesting because it has, rather than red, green, blue sort of specific wavelength sensors, like a lot of color sensors work, this is I believe, a luminance sensor, a blue sensor, and a red, yellow, green sensor. So it is closer to the way a human eye perceives color than a straight RGB. Also, it will give you the CIE values right out of the gate, so you don't need to do that conversion if you don't want to. And it also has IR sensing, so it can do adjustments for IR. And like I said, one of them is luminance. So you'll find that with a sensor like this, you can actually get some matching of color that is almost independent of luminance within reason. I'll show that in the demo. And let's go to the product page for this. So right here, you can see it is, whoops, I just brought a window up in front of my face. There we go. It is a half price right now, so $4.75. We had 100 of them in stock, 91 in stock, so people are buying them. Go put those in your cart if you want to get them before the show is over. And the page here has a little link to our primary guide, so if you check out Primary Learn Guide here from Tim C. You can see there's this nice little demo that Lamore had done there, which is showing those X, Y, and Z values as well as IR as some of those cafe lights are changing colors overhead. And there is a page here with pinouts, so you can go see how this board is laid out. There is a jumper for the LED, I believe. Where is that? On the back, yeah, there's a LED jumper. You can see a little better in these photos on the back there. And there's a very dim red LED when the power is on. So I think Lamore put a pretty big resistor on there so it wouldn't influence things. But if you really want to cut that, especially if you have this under dark glass, which happens sometimes, and you don't want any reflections, then you could cut that jumper there and get rid of the red LED, power LED entirely. And then we have setup here for CircuitPython and Arduino. And then in the download section, you can see we've got a data sheet as well as a color matrix calibration document and Eagle file for PCB on GitHub, as well as a fritzing file if you want to bring that into fritzing, which is very nice and convenient. If we check out the data sheet here, here's the product document from Osram. And I always like to check out some of their top level things, such as what's this used for? Okay, display management. So that's things like monitors, laptops, phones, camera image correction and enhancement, color sensing, ambient light sensing, optical identification, and color matching. And at this point, actually, I'd like to show another video, which is from Osram, which is a really nice demo, better than I could put together in a reasonable amount of time, of using this sensor in order to try to blend a display with a sort of poster board image. So check this out right here.
Hi, my name is Dave Moon, and I'm going to talk to you today about our paper-like viewing technology. The key benefits associated with the paper-like technology is the ability to change a display's white point from a cooler color temperature to a warmer color temperature to allow for a display to read like a piece of paper. We're showing two identical pictures here. Maybe you can zoom in a little bit here. The two identical pictures are two smartphones cut out in both displays. The smartphone on the right defaults its color temperature to a D65 color temperature, and the one on the right would as well. But the one on the left here also has our color sensor, our TCS3430. And this is a high accuracy XYZ tri-stimulus color sensor, which allows us to accurately measure the color properties of light of this environment and do a white point adjustment of a display. That adjustment allows that display to read like a piece of paper. So let's see how it works. So when we go from this cabin right here is illuminated at 6,500 Kelvin. And if we go to a warmer color temperature that might be found in an office environment, say fluorescent lighting at 3,000 Kelvin, and we turn that off and we turn on the, you can see how the white point on the display on the left here has adjusted, where the smartphone without the color sensor did not adjust. It's continuing to display copious amounts of blue light. And that becomes even more apparent when you go to a warmer color temperature. So let's turn off the 3,000 Kelvin bulb and turn on a 2,700 Kelvin bulb. And you can see the display on the left here, how it adjusted its white point. And you can see that, how the reds and the yellows and the pink flesh tones continue to flow continuously. Whereas over here, you can definitely see the large amounts of blue light. And when we go from an artificial light source back out to a natural sunlight environment, you'll see how it readjusts yet again, and now the pictures are identical.
Yeah, all right, that's a pretty cool demo right there. And let me do a little more of a data output, raw sensor output, and CIE color output demo for you here. So let me show you my setup here. So I've got the tri-stimulus color sensor right here. It's connected up to a Feather microcontroller, and I'm running Circuit Python. And next to it, you can see I've got one of these, a neat little book light. These act kind of like a bookmark. You clip them on a book, and you can turn them on. You've got 3 brightness levels there. I'll go to middle brightness, and you've got 3 color temperatures. So there's a incredibly saturated amber, there's a sort of neutral, and there's a bluish light. So if I set this here, let's go to this view right here. You can see, I'm going to bring up my my browser. I've got a little web serial application that I made using Claude that is outputting, as you can see across the bottom there, the raw X, Y, and Z values, as well as infrared. So that's the raw values coming off the sensor. And then just I'm remapping that to the CIE index, which is essentially 0 to 1. So CIEX and CIEY plot to this color chart. And if you see the little red crosshair with the numbers in parentheses there that match the values I'm getting right now, watch those change as I change the color temperature. So I'm going to hold this still here and just press the color temperature button. And you can see I've gone to cooler, coolest. Oh, I'm sorry, I'm changing brightness values there. That'll throw everything off. Just because of my environment in here. Here we go. Here's color temperature. So there's the most amber, and we scoot over to that red and yellow section of the chart. Here's the neutral. That's not updating properly, I don't think. Hold on, I'm going to reset the I have had this running for quite a while, so I'm going to reset this because that doesn't look right to me. Is that the reset? Yeah. Okay, give me a second. Let's try to reconnect that. Connect to Web Serial. All right, trying that again. There we go. Yeah, I'm not sure what was happening there. May have just buffered a ton of values or something. So there we go. There's the very amber, there's the neutral, and there's the blue. So you can watch those scoot across that there, leaving a little trail as they go. And the code that I've got running, let me hide the web display here for a second. Hide that. There we go. So that's my code there. Okay, so the key things in here, and you can ignore, I had some text, I had some code in here to push this up to a little display, more like Lemoore's demo there before I decided to do the Web Serial app. But the main things here is we're importing the library for the sensor, so TCS3430, import that. There are commands for adjusting the gain and the integration time. So there's a couple other things you can do, but the main thing you'll do is just simply ask for the XYZ values and IR value coming off of there. So during setup, I've got this set up on I2C. I'm setting gain to one of the presets, integration time. This is all text stuff for the display. And then in the main loop, I go X, Y, Z, and IR1 are going to be cast to these sensor channels. And then if there are changes in these, I'm going ahead and displaying them converted to the 0 to 0.1 values, and then printing them. And this is a particular formatting for the Web Serial there. But I think if I go ahead, I'm going to disconnect from the Web Serial and just connect to it here. I'm going to reset it so it'll let go of that old serial port. And there we go. So there you'll see same stuff that we're seeing on the chart there, raw values for XYZ, and then the IR as well as the CIE X and Y. And you'll see all of those change a lot as I adjust those colors on my light. So this is all you have to do really is just ask for sensors.channels and you'll get all the values that you need right out of there. So that is all I've got to say about this sensor. I just wanted to go to the chats briefly here in YouTube. Happy Hansha says, I wonder if this could be used to calibrate backlighting for stained glass work. I could take a reading of the piece, the place the glass is meant to fit in, calibrate my studio while selecting colors from my glass hoard. That's great. I use a light box to see how glass works together. That's very cool. Yeah, this could be the sensor for you. I'd be interested to learn more about what that process looks like of trying to match your colors. And let me go to the Discord chat over here. Todd says RGB is so passe, XYZ is the new hotness. Well, yeah, I guess for ambient light it is. I don't think you'll use this for things like color object sensing as much. It's more about ambient light, but I could be wrong on that. So I think that is going to do it. Let me bring this image back up here, and I'll grab this one off of here. Before I go, I will remind you, if you want to go grab one or more of these, head on over to that QR code, that URL right there. They are, as I said, oh, where'd my Safari go? Too many windows. There we are. They are $475 half price right now, normally $950, and you can pick those up. We got 87 of them in stock, so pick those up just a little bit after the show is over. The price will go back up, so don't wait on those if you're interested. If you want to get them at that good price. All right, and so that right there is my product pick of the week this week. It is the TCS3430. Tri-stimulus color sensor. For Adafruit Industries, I'm John Park. This has been JP's Product Pick of the Week. See you soon. Bye-bye.